So welcome everyone to Aleka Talks. Today we're talking about deep sea mining, and you're going to learn a lot of new terms. You're going to have to open your mind about what this could mean to providing a new stream of metals for all our electric vehicle batteries, all our solar panels. These all need new metals. So stay with us and learn how to be a leader of a sustainable future. Good. Looks good.
Okay, thank you very much. Now I will proceed with my talk. As I mentioned that actually the title of my presentation today is Deep Seabed Mining in Malaysia, Opportunities and Challenges. This is the joint paper between me and Prof. Dr. Wan Izzatul Asma from the Center of Ocean Governance, Institute of the Oceanography and Environment, University Malaysia Terengganu. So before I proceed, I would like to disclaimer any views given in this presentation are purely personal. My personal views of the author and do not represent the views of the my agency, JMG or UMT and other parties. So okay, this is our agenda today, or the outline of my presentation. I will introduce what is the deep seabed mining. Then after that, I will share where the deep seabed mining. Then third one is the function of the International Seabed Authority, or in short form is ISA, which is under United Nations. Then of course, the most important part is law, regulations, procedures before Malaysia embark in this deep seabed mining. So then we will look at the benefit and challenges, and also after that I will conclude my presentation. And lastly but not least is the most important is the way forward. What is what is the Malaysia especially in the deep seabed mining. So lately, strategic mining such as rare earths, or REEs, precious metal and deep seabed mining has received media and public attention both internationally and locally. It's cover on not only the resources and the importance of the mineral, but also the public or NGOs concern of the environmental impact on the minings. So last year, if you can see, Kedah MB announced of the REE resource in the Kedah is worth 62 billion in Kedah itself. You just then. You can see here from the news on the screen. In 2008, Japan discovered of REE of Japan coast actually secured 780 years of the industrial demand. You just imagine how big is the mud from the seabed of the Ogasawara Islands is somewhere 2,000 kilometers from southeast of the Tokyo. Contain high concentration of the rare earth element, and yttrium is the depth of is about 4 to 6 kilometer, or 4,000 to 6,000 kilometer. So actually in near future, deep seabed might be turned ocean into new industrial frontier. Now I would like to share with what is the COVID-19 and how the global mining industry impacted by the COVID-19. So this graph shows how the global mining industry affected by the COVID-19 pandemic. As we can see that the short term, I will point. Wait, I will point. Okay, you can see here that the short term affected after declaration of the COVID-19 pandemic in somewhere March in 2020. So the price of the metal, most of the metal, gold, platinum, palladium is drops. But after that, you can see that since the mining activity is considered as an essential services, it's not much affected compared to oil and gas industry. You can see here, is the green color is the Brent crude. So the oil industry is much more affected compared with the mineral or mining industry. So these studies done by the Simon M. July into last year actually in 2020. So now let's move to the our business today is why deep seabed mining. So why lately many countries venture in the deep seabed mining. So as you can see on the slide, the mineral industry is spending fast, coinciding with the increase in demand. And the second is the new use and market to promote actually the green and blue economy. I think all of you heard about the United Nations. Also, Malaysia is promoting our blue economy, which is economy related to the oceans. This is a new frontier economy actually for our nations. And the third one is the depleting land-based minerals has led to the seeking of the mineral resources, especially from the deep sea. And of course, deep sea bed mineral have high concentration of the precious metal in comparison to the land-based, as mentioned just now, the one that found in the Japan offshore. And of course, a lot of the country have started to explore and exploit the deep sea mineral. Thus, it is necessary for Malaysia to commence on the deep sea mining exploration to reap its economy and technology benefits. Malaysia, by embarking on the deep sea mining, of course, Malaysia will have the opportunity actually to seek new exploitable resources and establish deep sea industry in Malaysia. So in addition, Malaysia will be able to develop deep sea technology. This is the one of the importance. Geoscience field, resource investigation, exploitation and processing technology, as well as establish the onshore support services. This is the one, the important, that the drive factors why we need to start or to embark in this deep seabed mining. And now you can if you can see that actually what is the deep seabed mining actually. So actually it is a mineral extraction mining process in the deep ocean's floor. And why I did mention just now, it's a new resource for the minerals such as the polymetallic nodule, cobalt-rich ferromanganese crust, polymetallic sulfides, and the most important is now is REE is one of the strategic mineral, or even in our country or all over the world. So the second is a highly concentrated mineral, especially in the world high-tech industry. Now, if we look at the cosmetic, smartphone, table, electric car, wind turbine, and all this is a need high minerals, mineral need to support this industry. So where can we mine these minerals? Actually, the term is we use that is area, which is determined and regulated by the International Seabed Authority, or in short form is ISA, an international organization under UNCLOS 1982 under United Nations. So many countries actually have been granted license by the International Seabed Authority to explore and exploit or prospecting. So in area beyond the national jurisdictions, then we call this that is area for deep seabed mining. And the top 6 countries given the most contract is actually Russia, China, Germany, France, and also Republic of Korea, and also Japan. So this is actually more than that. I will share later. But these are the top 6 countries who given by the contract by the ISA. And where we can actually found these deep sea bed mineral occurrences, actually the most important is related to the geology of the area or the sea floor. So there are 3 main group of mineral, which is a seafloor massive sulfides. Second is a manganese nodule. Third is the cobalt rich crust. So you can see that such seafloor massive sulfide we can found at the mid-ocean ridges, which is the water depth between 350 to 5,000 meter, and also at the trench or subduction trench, and also the backup basin. But for the manganese nodule, we can found on the ocean floor, which is normally the water depth between 4,000 to 6,000 meter. And of course, the third one is cobalt rich crust. We can found at the normally at the sea mounts, which is the water depth between 400 and 4,000 meters. So this is the detail for the 3 group of the deep sea mineral. One is the polymetallic manganese nodule, as I mentioned, is found at the depth between 3,500 to 6,500 meters. So normally it contains chemical elements such as manganese, iron, copper, nickel, cobalt. This is the one, the importance mineral for the future or for the high-tech industries. A second is the polymetallic sulfides. You can see the photos. Normally we can found at depth between 1,000 to 4,000 meters, and this group is polymetallic sulfides consists of the copper, zinc, lead, gold, silver, as well as trace mineral. And third is the cobalt rich ferromanganese crust. Normally we can found at the 1,000 to 3,000 meters, and normally contain mainly manganese, iron, cobalt, nickel, and platinum, and also the REE. So this the photo shows by the GEMSTEC, one of the lead agencies looking for the deep sea mineral. And also here is from the JOMAR, from the ROV team, from the Kiel research team, and this one from the Netherlands, source from the Guardians, the photos. So this map actually shows the main occurrence of the marine mineral, mainly associated with the mid-ocean ridges and fractured zone on the deep ocean basin. You can see that the distribution of the cobalt crust, the manganese nodule, and the black smokers. So this map shows the polymetallic sulfide deposit on the seabed. So actually this yellow dot actually show the sampling location and the hydrothermal vent all over the world on the seafloor. And this map shows the mineral resources in the Southern Pacific Oceans. So it shows the sampling location from the ISA Center Data Repository. See, actually, the most of the data or map you can Google, and you can go to the ISA International Seabed Authority website. You can access, and if you want to get more detailed information about the resource.
So this is public information.
Yeah, actually public information. Everyone can access. You just go to the ISA website, International Seabed Authority website, which is based in Jamaica.
Cool, thank you.
It's a good map actually. Everyone can look at it. Okay, and now I would like to. I did mention about the just now about the REE. So why REE is actually is important. So as I mentioned, REE is one of the new strategic minerals and highly demand, especially in the IR 4.0 industry. Yeah. So it widely used. Actually, this is you can see the mineral. The REE can be classified as a light REE or HREE, and this the element that used in the industries. And the most important is if you have I'm sure everyone have a handphone. So all these cameras, circuits, battery, vibration, all actually made up by the RE minerals. And now people have the electrical car, and even a power window, actually the glass mirror all use the REE. And you can see the price. The price of the REE. This is based on the Sahai metal. In June last year, 2020, you just imagine this. You can see the terbium is about the 2 million actually per metric tons. So you can imagine how expensive is the price for the RE. So it is very expensive. The price ranging from the 7K to 2 million per metric tons. So another thing is actually REE is a strategic mineral. Why? Because it's highly demand, actually used in the defense industry. You can see that the mineral that used for the army, for the armed forces, for the bombs, for the aeronautical actually, for the aeronautical industry and so on. So this is the forecast that the mineral that total we need the mineral in future. So now I will move to the area. I did mention about just now about the area. So actually under Article 1, UNCLOS, I'm sure everyone maybe may heard about the UNCLOS, United Nations Convention Law of the Sea 1982. So stated that Article 1 stated that the seabed and ocean floor and the subsoil thereof beyond the limit of national jurisdiction actually referred to an area which is under the International Seabed Authority, ISA. And here is so we can divide it into one, the area that beyond the national jurisdiction is under ISA, but the area under the state jurisdiction, such as the territorial sea, 12 nautical mile from our baseline. The EEZ or EEZ is 200 nautical mile, and also the continental shelf under state jurisdiction, which is can be a maximum is 350 nautical mile under the Article 76, which is state can submit their to the United Nations under CLCS to claim more than 200 nautical mile for the continental shelf. So this cartoon shows the actually the figure shows the maritime zone and the rights under UNCLOS 1982. So the red box is actually the area that under UNCLOS Article 1 is the area actually for the common heritage of mankind. So it shows that the area of common heritage of mankind under ISA jurisdictions, and you can see also the general geology of the seabed here, the sediments, the continental crust, and also the mantle. And this is oceanic crust, which is where the mineral we can find the deep sea minerals. So actually the common heritage of mankind or CHM principle in under United Nations Convention on the Law of the Sea or in UNCLOS allow us to do this in a way that ensure the access for all and equitability distribution of benefit. So actually this area is under the common heritage of the mankind. So the people, all over the nation should benefit from the resource from this area. So this the same. I just to mention that I did mention about the that we can claim the our continental shelf more than the 200 nautical mile here. So under the limit of the continental shelf under Article 76, I think last 2 months Dr. Mazlan did share this continental shelf. So so the area is beyond this 350 nautical mile. So actually there are five main area and different type of mineral found for the deep sea bed mining. So you can see that one of the famous area is the Clarion-Clipperton Fractured Zone, which is famous for the polymetallic nodule. India Ocean, which is nearby here, near to Malaysia, is the polymetallic nodule and polymetallic sulfide. Mid regions Atlantic, which is the resource is the polymetallic sulfide. South Atlantic Oceans, which is a type of mineral that we can find is cobalt rich, ferromanganese crust, and the fifth one is the Pacific Ocean, where we can find the polymetallic nodules, cobalt rich, ferromanganese crust, and so on. So this map shows the exploration license already granted to several countries by SA in the Clarion-Clipperton zone for the polymetallic nodule. I just mentioned just now. This is one of the top important area for the deep sea bed license granted by the ISA. And you can see that our neighbor here is Singapore. Here you can see here, Ocean Mineral Singapore already got the license under the Ocean Mineral Singapore Mineral OMS here, which is marked by the green. So this is I would say that it could be a motivation actually for Malaysia to embark a near future for this deep seabed mining, because our neighbor already got the license under ISA.
So what are the terms? So the country gets awarded this. It's awarded to the flag, to the country, but then yes. The country is then what divides it up and awards it to different companies. What's the procedure?
Yeah, normally the application should come from the one company. It could be the GLCs, or it might be a small country, but company, but they get together to form what we call that the consortium. It may be consortiums, and then after that the country. I will share what is the how the country will if they want to apply under license under ISA letter. In my next slide, search I will share that. But normally the country should represented by the one company normally. So actually, this map show the exploration license in the India Oceans. So you can see the area here, and still there are area that still not granted license to any company yet. So it could be a area for the Malaysia, I think, because it's not far from Malaysia in their oceans. And then this the Mid-Atlantic shows the license, area or the area granted to for. You can see that for the Poland, the Russia, and also the France. Actually France. And actually the dot dash line red in yellow color, that the submission I did mention about the state can claim or can more than 200 nautical mile under what we call that extended continental shelf, which is the state can submit it to the commission for the limit of the continental shelf. So as mentioned by Dr. Mazlan, I remember last 2 months, in
That's
his
correct.
talk.
That's correct. We had
Yeah,
another talk about the how far the nation can claim, and it was a
yes,
very good talk.
exactly.
Take a look at our YouTube channel.
Yeah,
Dr.
yeah.
Hassan was very kind to have presented that.
So exactly. So actually, the area normally out must be out of the this boundary. Actually, the yellow the yellow boundary. This is the extended continental shelf. So this area is called the area or which is under high seas. High seas under UNCLOS 1982. So okay, this map shows the exploration area for the polymetallic in the Pacific Oceans. You can see the actually from China, Japan, Korea, Russia, and also the from also China in red color, Beijing, with China. China got not more than one area actually. Grant the ISA granted to the China. So actually the country can apply more than one license. So this map shows the southern Atlantic seamounts exploration. So you can see that here is Brazil, and also Brazil got the license or the area under ISA. So now I move the uh, topics. What is the ISA? So I would like to share the what is the International Seabed Authority. So actually, the ISA established in 16 November 1984 under United Nations. So headquarters in Kingston, Jamaica. And what is the composition of the ISA? The main body normally assemble council, legal and technical commissions, finance committee and secretariat. Then the assemble consists of the all member states, 180 UNCLOS member states, and sets normally this assembly set the general policy lah for the authority ISA, especially on the seabed minings. And the council consists of the actually the assembled is 168, but the council consists of the three member, 36 member, 36 members stated elected by the assemble. So the council elected during the assembly. So then also the LTE under Article 1965 to evaluate application, supervise the contractors and provide the regulation for the council consideration. So actually all four bodies meet annually at the ISA headquarters in Jamaica. And then the Secretary General is Michael Lodge, actually from the United Kingdom. And still because the term is 4 years starting from January 2070 until this year. So this year the assemble will elected election for the new Secretary Generals. And then I will share the budget. Actually the ISA has the what we call that biennial budget for 2020. Last year is USD 17.1 million for the operational and so on. And Malaysia actually has a party state since 1984 and has paid the working capital fund of the International Seabed Authority. The amount is about 28,000 USD in 2008 and almost 40,000 USD in 2009. So actually Malaysia every year paid the capital, the working capital fund for the ISA. So I hope that everyone get the a very brief of the ISA. You, as I mentioned, you can log into the ISA website, then you can get more picture about the
Yeah,
ISA.
we posted the link. There's the link there in the
Yeah,
chat.
good.
If you get any questions on that, please go to the link. You only have a few minutes left. You got about 10 minutes, and I know you had some awesome videos.
Okay, 10 minutes more. Okay. I will go very fast now. So anyway, this just to show I think I did mention just now how the organization of the International Seabed Authority, and I think all of you can get this from the website. I don't want to explain in detail. So then this is the ISA contract for the exploration until last year. I think end of last year there are 30 contract for explorations, and you can see that from the Southeast Asia only Singapore, Ocean Minerals Mineral Singapore, and I really hope that in near future Malaysia will be the second dot in this map. We hope that, we pray for that. Okay, now I move to the law and regulation, which is this is the most important if we want to embark for the in the deep seabed mining. So being a state party to United Nations Convention Law of the Sea, UNCLOS 1982, and also the Convention of the Biodiversity 1994, Malaysia has yet to develop a set of policy, regulation, and law related to deep sea bed mining to mitigate actually its effects to the environment, coincide to the requirement of the convention. As I mentioned, so in order Malaysia actually to embark in this industry or in this deep sea bed minings, so one of the under UNCLOS, the state must have deep seabed mining legislation or law which is comply with the UNCLOS 1982 and ISA mining code. So now, as we in Malaysia actually is not ready yet actually, because Malaysia is not for the time being, Malaysia has not has the legislation or the law or the act which is for the deep seabed minings. So this just to share what is the DSM legal framework or provisions. So if you want to come up with our own legal framework, the legal or the acts or the laws, this is the framework actually we should follow. Okay, this is the procedure for the deep seabed mining. So as I mean just now, Mr. Search asked how the country or the company can apply. So the first thing is the contractor must refer to the country or the company. So must identify type of the deep sea mineral and part of the area to explore. After that, apply for the approval. 15 years normally plan for work for the exploration contract. Normally I say granted for the 15 years contract. Then after that, the contractor must shows the financial and technical capability to carry out the proposed plan of the work. After that, the company should have the schedule, let's say for the program for the 5 years, and also the most important is the research and study that will be done in the respect to the marine environment, also the possible impact if we mining activities, and propose the prevention and the control, how to minimize the environmental impacts. So now I share with in terms of the cost if we want to embark in this deep sea mining. So it's not the cheap. I mean the industry. So as you can see that actually for the exploration, at least we need for the 120 million for the ship for the exploration, and technology and machine is about 241 millions. and for the cost of the processing and so on is about the 544 million, and actually the estimated cost, total cost is almost 1 billion. So but the second, actually the cost is stages. So maybe the first one is the most important, is for the exploration. So we need the ship, technology and machine, and this after we want to embark in the real mining activities.
So this is a commitment. You make this commitment to the ISA then under the terms of the contract, and
not really, but we should shows that we have our capability in terms of the cost to venture in the industry.
So conceptually, you could get awarded the license and not spend anything.
Yeah, of course.
Yes, it's not like oil and gas concessions where you make a commitment and you're served a penalty.
Yes, of course. Yeah. So the country or the contract must shows the capability actually to start with the let's say exploration and so on. So just this as mentioned, Search mentioned about the cost and benefit analysis. I just to share one of the study by the European country, European unions, and assessment of the cost and benefit of the mining deep sea minerals in the Pacific island regions. So you can see that for the Papua New Guinea, actually the resource is seafloor massive sulfide. So total cost is zero. This is based on the USD in millions. So you can see that in terms of the cost and the benefit is ratio is 134. So you can with the cost, of course, as I mentioned, it's maybe 1 billion, but the benefit after the revenue is more. More than that. So for example, for the Cook Island manganese nodule, is 18 in terms of the ratio between the cost and the benefit. This is one of the indicator. Actually, there are many studies in other part of the world that we can see in terms of the cost and benefit. And the recent study also we can get. This is the one that I want to, maybe one example to share with all of you today. So now, before I end of my presentation, before I go with the conclusion, I just to share a few videos with how the exploration of the deep seabed minings. So this is the exploration, the first stage of the deep seabed mining. We need to explore to first is to get the area from the ISA. Then you need to carry out the surveys to get the detailed information of the where is the deposits and what is the type of the minerals, and how about the reserve or the resource and the reserve, either it's economic or not. So as I mentioned, this it need a highly costing, because we need the vessel, and this is the show that how we can sample the minerals from the deep seabed. So as I mentioned, the seafloor is about 1,000 to 6,000 meter actually. So this is the detailed survey carried out after the preliminary survey. Actually, this is the targeted area, which is the smoke. This is one of the targeted area, and this is how the technology we want to sample the what we call that vents, smoky vents on the ocean floors. So this the ROV and how the ROV take the sample for the analysis to get the contents of the minerals. So, okay, and now
you had mentioned once, one of the questions in the chat is any reason why polymetallic nodules are only found between certain depths?
So actually, it's normally related to the geological processes. The geological processes, which is that's why some of the mineral we can found at the subduction zone, as I mentioned just now. So it's closely related to the geological processes of the ocean floor.
Okay.
Okay,
well,
now
we have a few questions, so let me know when you're ready.
Okay, I will share my second videos. So this shows the real video. Using the ROV. The depth is about 5,000 meters from the mean sea level. You can see this the group of the mineral on the seabeds. So you can see that at the depth of the 4,000 to 5,000, 6,000, there are still living creatures. You just imagine the temperature here is more than 100 degrees. Yeah, that's just degrees Celsius, and still, you can find living creatures here. You can see here just now. And here the what we call the shells on top of the seabeds. Okay, now my last video is just to share the concept of the model. Actually, the technology is already is ready now. Only the company or contractor waiting for the mining codes to be approved by the assembly to start the mining operations. So this is the oh wait, I will share the okay. So you can see how the technology, the equipment, how the model to carry out the deep sea bed minings. So this is the technology already developed by the countries such as Japan, Korea, China, US, European country, and so on.
Looks similar to oil and gas operations in deep water.
Yeah, of course.
So would you say that the Japanese, the Koreans, and the Chinese are well ahead in the world on these things?
Yes, exactly. Because I have a chance to visit Korea, Japan, China for to see how they develop all this technology. Most of them ready to to start the deep seabed minings. Only waiting for the mining codes to be approved by the ISA assembly soon. Of course, so this is how the
So one of the questions in the chat was if it's for all of mankind, how do we ensure all countries, rich, big, small, wealthy, the poor ones as well, how do we ensure all of mankind benefits?
So okay, that's why the license granted by the ICA through to the states contractor. So the state actually must pay to the ICA at certain amount in the contracts. Let's say from the revenue of the minings. So from that money, so we deposited in the United Nations. So that money will use for all over the world. I mean the people, the states, and the United Nations.
So anyone who gets benefits from United Nations programs would benefit from the revenue from these mining operations.
Yes, of course. Exactly, Serge.
Okay.
So now I will maybe I have 2-3 slides before I conclude. I will just to share. Okay, this is the benefit. Of course, if you want to embark in the deep sea mining in future, of course there are a few benefits, such as the sustainable production of the future resources. Of course, a mineral concentration at the seafloor greater than land, to ensure the supply of the metal for use in the efficient and clean technology. Environmental impact of DSM not be as severe as the onshore mine, but this still question mark, because it's a lot of research that have been carried out. And deep sea mining are world-class resource of the mineral for the development and industrializations, and as a source of the enormous wealth, as I mentioned, in blue economy. And of course, the most challenges, the need to develop management regime to govern the mining activities. Of course, we need to have the law first. The second is required high-end technology equipment such as machine and ships. Third is we have to Malaysia has to establish the implement new policies and law. Of course, companies seeking to engage in the seabed mining mineral activity in the area of the national jurisdiction will operate subject to the policies and law. And fifth, could have serious impact on the ocean environment and well-being of the coastal communities. And last but not least, extremely high cost, as I mentioned just now. It needs 1 billion at least to success in the deep seabed minings. This one I will skip. And as for conclusions, having the legislation in the place would be the overcome is the first hurdle for Malaysia to embark for the deep sea bed minings. A special committee which is comprises of the researchers, governments, and stakeholders, including the affected populace, should be established. The expertise technology and the financial issues need to be resolved. Only then would Malaysia be ready to embark on the extensive deep seabed mining. Of course, Malaysia must establish its own deep sea mining laws. This is the most important, the first thing we need to do before we start. And it is essential to have the comprehensive governance framework, including the policies and the administrative measures to ensure the effective implementations and enforcement, particularly in the matters related to the health and the marine environment, which is now United Nations launched the Ocean Decades, which is from this year and into 2030. So one of the important issues is the marine to have the sustainable marine ocean developments. And last but not least, Malaysia would be ready to embark on the deep seabed mining if this issue can be resolved. And the way forward is, of course, we need to have the fundings. We need to have the consortium of the companies. And second is we need to develop our technical experts by the trainings and so on. And third is the governance framework. We have to sit together, not working in silo with the industry and with the NGO and so on. And the most important is the database. We need to have our database, because now we talk about the what we call the big data and so on. And of course, the fifth one is coordination between other interagencies, NGOs, and also the companies. I think with that, thank you very much, Serge.